Hello students, this video is being recorded in the summer of 2020, right after the end of the spring semester and in the midst of the ongoing COVID-19 pandemic. Since we do not yet know for sure what format our classes will take in the fall, and since there's some likelihood that at least some of us, both students and faculty, will have to be away from campus for a time should the mitigation plans prove ineffective, or should compliance with or enforcement of public health guidelines prove impossible, I am preparing a video version of each of my lectures for the class to have it ready if and when it is needed. It's also the case that necessary distancing requirements in the classrooms may make it impossible that the entire class can be in the same room at the same time. In that case, those whose turn it is to stay away from campus may find these video lectures a better option than relying on a live classroom feed via Zoom or some other technology. So if you're watching this video, it means that we are, for reasons of public and personal health, still unable to meet together in a traditional face-to-face classroom format. All the same, I'll continue to do my best to teach you what I know with whatever tools I have at my disposal. Enjoy the lecture. So our next lesson in deductive reasoning focuses on logical equivalence. And we had a brief introduction to this when we reviewed exercise 13, because several of the examples there were universal negatives, and we talked about the possibility of using conversion to get an additional correct answer. And those additional correct answers were correct because they were logically equivalent statements. And so what we want to focus on here today is the different ways, the different operations we can use to generate logically equivalent statements for any two-term statement. So just as way of review, remember that we have the four forms of two-term statements: universal affirmative, universal negative, particular affirmative, and particular negative. And each of these types of statements, first of all, expresses a relationship between classes or categories of things, people, ideas in the real world. Those classes or categories represented by the terms. So each statement then gives us a specific subject term and a predicate term. Each statement also has a quality and a quantity. And so this is, of course, just review, but we want to make sure we understand that as we move forward, because it's these basic forms of two-term statements that we're going to start with when we generate logically equivalent statements. So we want to know, how can we express the same categorical relationship using different statements? That is, how can standard logical form statements be translated into additional logically equivalent statements? We know that each two-term statement in standard form can be translated into three equivalent statements, which would give you, of course, in the end, four altogether: the original statement and three logically equivalent statements. So there are three different operations that we can use to create a logically equivalent statement. And the first one we want to talk about is called obversion. And obversion can be used with any of the four types of standard logical form statements. That is, you can use obversion regardless of what type of statement you're starting with. It can be used for universal affirmative, universal negative, particular affirmative, or particular negative. Obversion generates a logically equivalent statement, and it is a two-step procedure. So we'll review those two steps. In the first step, you change the quality of the predicate term, right? So remember, we've talked about how every term which participates in a universe of discourse, every term also has a complementary term, so that the term and its complement together make up the universe, or make up the universe of discourse. So when we talk about changing the quality of a term, we're talking about, in essence, substituting its complement. So to change the quality of the term, substitute its complementary term. So if the term is students, you change it to non-students. That is, you substitute the complementary term. So the first step in obversion is to take that original two-term statement, locate the predicate term, and then change the quality of the predicate term by substituting its complementary term. And then once you've done that, step 2 is to change the quality of the whole statement, which is to say, if the statement is affirmative, you make the statement negative. If the statement is negative, you make it affirmative. And it's important, I think, to emphasize here, you do not change the quantity of the statement. If it's universal, it remains universal. If it's particular, it remains particular. You're just changing the quality of the statement. So a universal affirmative would become a universal negative. A particular negative would become a particular affirmative. So you're changing only the quality of the whole statement after you have substituted the predicate term by replacing it with its complementary term. So step 1, change the quality of the predicate term, and step 2, change the quality of the whole statement. So here's an example of obversion. So this would be the original statement in standard logical form. It's a universal affirmative statement. All rhetoricians are archival enthusiasts. So step 1, change the quality of the predicate term, which means we look at the predicate term archival enthusiasts and we substitute the complementary term for that predicate term. So it becomes, after step 1, all rhetoricians are non-archival enthusiasts. But of course, we're not done yet. We then move to step 2 and change the quality of the whole statement. And when we do that, we change from an affirmative statement to a negative statement. Again, not changing the quantity, it remains universal, but we change only the quality, so it becomes negative in this case. So the final and logically equivalent statement to the original would be, no rhetoricians are non-archival enthusiasts. So we can see this visually if we have archival enthusiasts and non-archival enthusiasts. There's our universe of discourse, in effect, showing both the predicate term and its complementary term. And then we add in our subject term, rhetoricians. All rhetoricians are archival enthusiasts. We see that the full category of rhetoricians is entirely within the class or category of archival enthusiasts. That's what the original statement says. All rhetoricians are archival enthusiasts. And then if we undergo obversion, we change the quality of the predicate term and we change the quality of the whole statement, and we end up with the obverted term, that is the logically equivalent statement through obversion, and that statement is represented by an identical Venn diagram. And your Venn diagrams, your visual displays will not change if your logically equivalent statement is correct. So take a look at this obverted statement. No rhetoricians are non-archival enthusiasts. You can see the whole category of rhetoricians here in the yellow circle. And of course, none of them are in the group of non-archival enthusiasts, which is entirely outside of the class of archival enthusiasts. And so we know then that we've got a correct logically equivalent statement because our Venn diagram remains exactly the same. So that's obversion. Here's the obversion example for a universal negative. No UFO witnesses are non-believers. So we change the quality of the predicate term, and notice here we began with non-believers as the predicate term, so the complement is simply believers now, right? So we change the quality of the predicate term, then we change the quality of the whole statement, and so it becomes now a universal affirmative. All UFO witnesses are believers. And so you can kind of sense as you read both of these that they're effectively saying the same thing. That's what makes them logically equivalent statements. But you can check yourself again looking at the visual display or the Venn diagram for these two statements. We have non-believers and believers, right? That's our predicate term. And then we have UFO witnesses, right? So no UFO witnesses are non-believers. That's represented here. And then we have all UFO witnesses are believers, right? Well, let me back up there. All UFO witnesses are believers. So if we go back even further, we can see believers is entirely outside the non-believers, right? And that's exactly where we find the UFO witnesses. So then here's an example for particular affirmatives. Some equestrians are Zinfandel drinkers. We change the quality of the predicate term, so Zinfandel drinkers becomes non-Zinfandel drinkers. Equestrians, the subject term, always remains the same in obversion. So we change the quality of the predicate term, then we change the quality of the whole statement. The some are statement becomes some are not. And so the logically equivalent statement would be some equestrians are not non-Zinfandel drinkers. And again, we can see that with the Venn diagram. We have Zinfandel drinkers and non-Zinfandel drinkers. There's our predicate term in the complement. And we have equestrians. Some equestrians are Zinfandel drinkers. We're talking about that overlap group there. And it's also the same visual representation when we say some equestrians are not non-Zinfandel drinkers, because non-Zinfandel drinkers would be everything outside the Zinfandel drinkers circle. And we see that indeed, because there's some overlap here, there are some equestrians who are not outside that circle, that is, not non-Zinfandel drinkers. And then we have the particular negative example for obversion. Some radicals are not political theorists. This starts with a particular negative. Step one, change the quality of the predicate term. So the predicate term political theorists becomes non-political theorists. So far, we haven't changed the subject term. We haven't yet changed the quality of the statement, just the predicate term. And then we change the quality of the whole statement, which now becomes a particular affirmative. Some radicals are non-political theorists. And so again, we can test this with our Venn diagram. We have political theorists and non-political theorists. That is our predicate term and its complement. We also have the subject term radicals. Some radicals are not political theorists, right? We're talking about the radicals outside the political theorist circle. And indeed, if you look at the two statements, right, you have the some radicals are non-political theorists. You can see that clearly here. We're talking about those radicals outside the political theorist circle. So the Venn diagram is identical for both statements. Some radicals are not political theorists, the original statement, and some radicals are non-political theorists, the obverted statement, the logically equivalent statement. So that is obversion. And then we have our second operation, conversion. And conversion is the one that we briefly introduced in homework exercise 13. And as I mentioned there, conversion may be used with universal negatives and with particular affirmatives. And be careful about this. Conversion is only used with universal negatives and particular affirmative statements. If you try to do conversion with a universal affirmative or with a particular negative, you will not get a logically equivalent statement. So one of the things you have to remember is what kind of operation may I use with each of the types of statements that I'm trying to generate a logically equivalent statement for. So conversion actually involves only one step, so it's easy to remember. And that one step is to switch the position of the subject term and the predicate term. And we saw that we did that a few times on exercise 13, or that it was possible to do that a few times on exercise 13. So to convert, simply switch the position of the subject term and the predicate term. So here's an example applied to a universal negative statement. No cello players are wrestling fans. There's our universal negative, the original statement, and then we switch the position of the subject term and the predicate term, and we have no wrestling fans are cello players, and that is a logically equivalent statement, which means it simply means it expresses the same relationship between the categories represented by wrestling fans and cello players as the terms in the statement. Because it's universal negative, or because it would be particular affirmative as well, you can switch the position of those classes or categories, those terms, without changing the relationship between them. And that's why you're allowed to convert this type of statement. So we have cello players, and we say no cello players are wrestling fans, right? And we can then convert the statement if we want to, right? And we can say no wrestling fans are cello players. And then here we can see it in the Venn diagram. No cello players are wrestling fans, no wrestling fans are cello players, and the Venn diagram would not change with either of these universal negative statements, even after you've converted the statement. And then we have the example for a particular affirmative. Remember that you can use conversion with a universal negative or a particular affirmative, but only for those two types of statements. So the particular affirmative original two-term statement, some hybrid cars are unreliable vehicles. We switch the position of the subject term and the predicate term, which is all it takes to do conversion. And we get the logically equivalent statement, some unreliable vehicles are hybrid cars. So we have some hybrid cars are unreliable vehicles. Some unreliable vehicles are hybrid cars. Right? If we look at that visually, some hybrid cars are unreliable vehicles, which means also some unreliable vehicles are hybrid cars. We have the class or category of hybrid cars. We have the class or category of unreliable vehicles, and we can do the original statement, some hybrid cars are unreliable vehicles, and some unreliable vehicles, right, are also hybrid cars. So particular affirmative conversion. And then our final operation is called contraposition. And contraposition may be used with universal affirmatives and particular negatives. And it may only be used with universal affirmatives and particular negatives. You cannot contrapose universal negatives or particular affirmatives because you won't get a logically equivalent statement. So again, one of the things you have to remember is you can use obversion with any statement. You can use conversion with universal negatives and particular affirmatives, and contraposition with universal affirmatives and particular negatives. So contraposition involves two steps, and the first step is change the quality of both terms. We learned how to do this with Obversion, simply substituting the complementary term, but in this case, you do it for both terms, not just the predicate term. So you change the quality of both terms and then convert the statement, that is, switch the position from the subject to the predicate and from the predicate to the subject term. So those two steps for the operation contraposition. So here's an example of contraposition on a universal affirmative statement. All gamblers are fools, a universal affirmative statement. Change the quality of both terms, which means substitute the original terms for their complementary terms. So it becomes all non-gamblers are non-fools. But that's only the first step. We're not done yet. You must then convert the statement, right? So it becomes, in the end, the logically equivalent statement, all non-fools are non-gamblers. And then we can look at this visually. We have the original statement, all gamblers are fools, and the logically equivalent statement after contraposition, after the two steps, all non-fools are non-gamblers. Here's our original predicate term, fools, and its complement, non-fools. We have the original subject term, gamblers, and indeed, if we take that first statement, all gamblers are fools, we see that represented here. But then we look at the logically equivalent statement, non-fools, right, which surrounds the whole diagram here. And the statement says all non-fools are non-gamblers. That is, everybody in the category of non-fools is outside the category of gamblers. And so we have a logically equivalent statement without changing the visual diagram. So all gamblers are fools is the same as all non-fools are non-gamblers. And then here's an example for a particular negative statement, again, for contraposition. The original statement, particular negative, some Serbians are not non-archaeologists. And again, note that in this case, the predicate term starts with what sounds like a complementary term, right? Change the quality of both terms. So Serbians becomes non-Serbians, but non-archaeologists becomes simply archaeologists. We're not changing the quality of the statement here. It remains a particular negative. And then the second step is to convert the statement. Remains particular negative, but we switch the position of the subject and predicate terms after we have changed the quality of both terms. And so we end up with a logically equivalent statement. Some archaeologists are not non-Serbians. And that's the logically equivalent statement, which can be represented with the same, that is, with the identical Venn diagram. Some Serbians are not non-archaeologists is the same as some archaeologists are not non-Serbians. So here we have Serbians and non-archaeologists. That's our original statement. And we have the category of archaeologists outside of the category of non-archaeologists, right? And so we are saying, in effect here, right, some archaeologists are not non-Serbians because there are Serbians within the category of archaeologists. There's the non-Serbians. So some archaeologists are not non-Serbians because they're inside that green circle, which is also inside the square or rectangle of archaeologists. So some archaeologists are not non-Serbians. And the diagram doesn't change. It's the same for both the original statement and the contraposed statement. So here's an example now of an original two-term statement, in this case a universal affirmative, and all three operations being used to generate three logically equivalent statements to that original statement. So the original two-term statement says all gardeners are brewers. If we use obversion, we end up with no gardeners are non-brewers. That is, we've changed the quality of the predicate term, then we've changed the quality of the whole statement. We end up with no gardeners are non-brewers. And we can go back to that original statement, all gardeners are brewers, and we can contrapose it because you can use contraposition with a universal affirmative. And in that case, we change the quality of both terms and then convert the statement. So we end up with all non-brewers are non-gardeners. And then we go back to the original statement, which is then obverted. And once we have obverted it, you notice it is now a universal negative. So the obversion of the original statement, because we changed the quality of the whole statement, the original universal affirmative becomes a universal negative. And so we can take that obverted statement, the universal negative, and we can convert that. We can't convert the original, but we can convert the obversion. And so the conversion of the obverted statement is no non-brewers are gardeners. And so this is how we would generate for any two-term statement three additional logically equivalent statements using the three operations of obversion, contraposition, or conversion. Here's another example. Universal negative. No NASCAR drivers are poets. That's probably not true, but we use it as an example. Anyway, no NASCAR drivers are poets. The obversion would be all NASCAR drivers are non-poets. We can also convert the original, because it's universal negative, no poets are NASCAR drivers. And then go back to the obversion. We started with a universal negative, but the obversion then gave us a universal affirmative, which we can then contrapose. So we can contrapose the obverted statement, and we get all poets are non-NASCAR drivers. And here's another example, a particular affirmative. Some entertainers are degenerates. Obversion of that original statement, and I like to use obversion first because you can use it with any kind of statement, but you can do it in any order that you want. The obversion of the original statement, some entertainers are not non-degenerates. Remember, to obvert, you change the quality of the predicate term, then you change the quality of the whole statement. But we're working here with an original particular affirmative, so we can also convert that statement. The conversion of the particular affirmative is some degenerates are entertainers. But then again, we can contrapose the obversion, which is now a particular negative, and the contraposition of the obverted statement is some degenerates are not non-entertainers. So again, we're working with the obverted statement. We've changed the quality of both terms, and then we've converted. That's the contraposition. Some degenerates are not non-entertainers. Here's a particular negative. Some red squirrels are not seed eaters. The obversion, some red squirrels are non-seed eaters. The contraposition of the original, which is a particular negative, some non-seed eaters are not non-red squirrels. And then the conversion of the obverted statement, which has become now a particular affirmative after obversion, some non-seed eaters are red squirrels. And again, you can draw a Venn diagram for any one of these, and it will be identical for the other three. So the original statement and the three logically equivalent statements. So what do we do with this one? Doctor Who is a Time Lord. Doctor Who is a Time Lord. What kind of a statement is that? First of all, it's important to note that when you get a subject term, or a predicate term for that matter, but when you get a subject term especially, that is an individual, that is, there's only one member of the subject term class, the subject term, the statement, I should say, is always a universal statement because you can't talk about part of a person. So if it's a single person or an individual or a unique institution or something, when there's only one member of the class, it is always a universal statement. So this would be a universal affirmative statement. Doctor Who is a Time Lord, right? All Doctor Who are Time Lords. That's the original statement, universal affirmative. The obversion would be no Doctor Who are non-Time Lords. The contraposition of the original would be all Time Lords are non-Doctor Who. And the conversion of the obverted statement would be no non-Time Lords are Doctor Who. And so from the original natural language statement, we get the standard logical form statement, then the obversion, the contraposition, and the conversion of the obversion to get the three logically equivalent statements. So our final example here is of reverse identification. So we'll start with a natural language statement and generate a standard two-term statement in standard logical form. And then I will generate three logically equivalent statements, but I want you to think about what operation did I have to use to get that logically equivalent statement, right? So I have the original natural language statement, Paddy Keenan is a magnificent piper. Again, because Paddy Keenan is an individual, we know this is going to be a universal statement, and it's obviously also affirmative is, right? So we have in standard logical form, all Paddy Keenan are magnificent pipers. Now, if I tell you this is a logically equivalent statement, what have I done to generate that logically equivalent statement? If you look carefully at it, you'll see that the subject and predicate term have been replaced by their complements, and the subject and predicate term are in a different place. That is, they've been converted. And so you should recognize that in this first logically equivalent statement, we have the end result of contraposition. Now here's another logically equivalent statement. And if you look carefully here, it says no non-magnificent pipers are Paddy Keenan, right? So look not at the original statement, but at the contraposed statement. We see that if we look at the contraposed statement, the predicate term quality has changed and the quality of the whole statement has changed. It now becomes no non-magnificent pipers are Paddy Keenan, which means what we've done here is an obversion of the contraposition, not working on the original two-term statement, but on the contraposed statement. We've then obverted the contraposed statement to generate the second logically equivalent statement. And then finally, we could say that no Paddy Keenan are non-magnificent pipers. And what we recognize here is that we have simply converted the obversion of the contraposition, right? So we take that that statement, the second logically equivalent statement here, no non-magnificent pipers are Paddy Keenan, which is a universal negative, and we know we can convert universal negatives, and that gives us the third logically equivalent statement here, no Paddy Keenan are non-magnificent pipers. And indeed, if you look at that statement, it's not only the conversion of the obverted contraposition, but you can go back to the original and it is the obversion of the original. So if you keep doing this, you'll keep generating the same three logically equivalent statements and the original two-term statement, because there's only going to be four possible logically equivalent statements. So again, go back to that original all Paddy Keenan are magnificent pipers. Do the obversion, becomes no Paddy Keenan are non-magnificent pipers. And that result, the obversion of the original, turns out also to be the conversion of the obverted contraposition. And so on your homework exercise, what I want you to do is look at all of the examples that you have, the original two-term statements, and generate the logically equivalent statements for those statements. Eventually, you'll do this on the quiz too, and on the quiz, you'll need only to generate two logically equivalent statements, but you will need to know all three operations because you won't have, in every example, the same type of original statement. So that's logical equivalence and a review of the three operations for generating logically equivalent statements: obversion, conversion, and contraposition. Make sure that you know which types of statements you can use those operations for: obversion for all four types of statements, contraposition with universal affirmatives or particular negatives, and conversion with universal negatives and particular affirmatives. So if you have a question about logical equivalence or about any of these operations, or if you have a question about any of the examples in this lecture, please post your questions to the discussion board. And as we fade out here, I'll play you a little bit of Paddy Keenan.